Hello guys, let's see this time how we can create REST APIs with the help of Node.js and Express for serving them. So we'll be testing them with Postman, and also they will make queries to a MongoDB database. Alright, let's start. So first we'll download the latest version of Node.js. We'll grab it from Node source. So we go to GitHub project of Node source, and here we see installation instructions. First we have to download the package repositories and add it to our main repository, and then to install Node.js. I already did this, and here in the terminal you can see Node minus version that we have installed, the current version here. Next we'll continue with the installation of other dependencies. First we'll create our project directory. So let's go to our main directory of the user, and from here we'll create a directory called API, and we'll enter inside. Since we have npm installed already with the node, we'll initialize our project. So we'll type npm init, and here let's name the packages REST API. Alright, no capital letters, so REST API version 1, description, creating REST APIs. The entry point will be index.js, and here we can type our name. Everything is correct. Now our project is created. We'll just do a simple npm upgrade, because we see that there is a new version of npm in the meantime released. npm is updated. Now let's install Express server. So type npm install Express. Actually, Express will help us to build a web server on top of Node.js. Now we can take a look at what we have in this directory. We have package.json and package.json log file. Inside of the package.json, we see that the Express is added inside of our dependencies, and all the other information we just filled. We'll also install MongoDB. We'll type npm install MongoDB, and then also Mongoose for communication with MongoDB. So after this operation finish, we'll see that they are also installed under the dependencies here of our project. The purpose of installation and putting those packages and their version names inside of package.json is that we don't need to distribute our Node modules directory, because it contains a lot of files. We'll just need this package.json file, and the next developer or user of our package will be able to automatically, with npm install, to have the libraries installed on their system. So it's a very convenient way of developing applications. Next, we would like to use some ECMAScript version 6 features inside of our project, as well as we would like Node.js to understand also those advanced JavaScript features. So we'll install the following packages. We'll use Babel for the process of transpile, where our code will be transpiled to more understandable for the browser's code. So we'll type npm install, this time in the development dependencies, so save dev, and here from Babel package we'll get preset environment, then Babel core and Babel node. this package preset environment will actually provide alternative versions of our code for other browsers, and the package Babel Node will be helping Node to understand the new features we are providing within our code that we are about to write. Alright, Babel is installed. Let's again check what's inside of our package JSON. We see now this new section, dev dependencies, and there we have Babel. This is because when we are shipping our application, we don't need those to be provided for the user. They are just for us as developers. The next thing we're about to do actually is to configure Babel. That's why we'll create one file, Babel RC, and inside we'll provide the following object with a key of presets, and here we'll just use the default Babel preset environment. So this is just the basic configuration. If you would like to provide different browser versions to be supported, you can see this inside of the documentation of the project. Alright, we save the file. Now Babel is configured, and we'll install Node Monitor. So we'll type npm install Nodemon. Again, in the development section, we'll use this package to automatically refresh our Node server without needing for us to stop the server and again start it with our files in order to see the changes. So it will save us a lot of time. Okay, and now let's change the starting script inside of our package JSON. So we'll edit it again with nano. Here we see that the starting point is index.js. This will be the file which we'll be executing, and from the scripts we see command test. So we'll replace this command with start, and here we'll use node monitor. So we'll type nodemon, and we'll use the Babel node. We'll provide index.js as a starting point. This means that the moment we will type npm start, this part will be started. So let's try to run npm start, and we see that we are starting exactly the same command here. So far we don't have index.js. We can create such, and let's log something on the console. We save the file, and again we'll run npm start. We have a little mistake in the package JSON. Here in front of exec we have 2 dashes. Alright, let's now run our code, and we see starting Babel node index.js, and this is from the node monitor, and we see our output hello from Node. Now our server runs inside of our console. Let's see how we can create a little web server which will serve the same content on the screen. So for this we'll use the Express framework. Inside of our index.js we'll import the Express library. I'll be using Visual Studio Code, and I'll be starting it from this directory. It's useful to have some highlighting on the changes of the files. So now actually we'll start coding our application. Inside of index.js we'll create our application using Express. Alright, the next thing we'll do is to use a port. So we'll define port as 4000, and let's define our first entry point for this app. If we are requesting or making GET request to the root of the web server, then we would like to send in the response that our server is running. Okay, now the last thing we're about to do inside of this file is to listen to the port. So this is the defined port, and the moment our application starts listening on this port, let's say we'll write the application is listening on port, and here we'll use the port constant. Okay, so basically we are requiring the Express library, we're defining a port, and then we are creating here one function which will be run when someone is requesting our web server on port 4000. Let's save the application, and actually we can use the internal terminal here in Visual Studio Code to run the code. So we'll just type npm start here, and we see that we have an error. Let's see what's the error. We see that Express is not defined. Of course, we haven't imported the library, so we'll type import Express from Express. Okay, this should fix the error. The moment we saved, our Node monitor is calculating the changes and again running our code. Again, another mistake. We haven't defined properly the port. We're saving again. We see app is listening on port. We haven't used the proper quotes here. Save. And we see that the application is listening on port 4000. We can check this out in our browser. So if we open local host on 4000, we see server is running, and that's the output from this URL here that we're listening on. Okay guys, we have now the basic application running. Let's connect to MongoDB. We already have installed MongoDB, so if we type Mongo, we'll see that we are inside of the database. We'll use Mongoose to connect to the MongoDB, so we'll import it first. And let's say here we'll connect using Mongoose. So Mongoose connect. We see this feature is enabled, and here we have to type our connection string. So it is MongoDB, the protocol to localhost, and a database which we like to connect to. Let's say it will be MyDB. We'll pass some options to the connection. We'll pass them in an object, and those will be to use the new URL parser, and it will be set to true. The next will be use unified topology. Again, it will be set to true. This is just to remove certain errors that might occur while connecting. Okay, this is our connection string. Afterwards, if we have errors, we can use to catch those errors. Let's grab the error and log it on this console. So that should be it. Let's comment those two lines for now and just try to connect to Mongoose. We save. We see no errors. This means that the connection is happening without problems. Now let's edit the structure of our project. Right now we only have Node modules as a subdirectory. We'll create one subdirectory called source. So mkdir source. Inside of this subdirectory, we'll use the MVC pattern. So we'll have our modules, roles here, and controllers. So let's start with the roles. Actually, we'll create one new file, roles .js. So we'll enter the directory, and from here roads.js, and I'll directly paste what we'll have inside of the roads and briefly explain everything. So basically we're having two main routes. One is when we're browsing our user, and we'll have two sub-routes. So when we type /user and we are requesting it via the get route, as a response we will getting information about all users. And if we are using a post request, we'll be creating a new user. Then we have routes for a specific user. As you can see, we can send a specific user as a parameter, having a semicolon in front of the user ID. And then we'll have three routes, maybe delete, not for now, get and put. If we are requesting certain user ID, we'll return specific information about this ID. And if we use put method, we'll be updating a specific user. So if we pass a user with ID 5 and information about this user via put request, we'll be updating the information about this user. Okay guys, so basically we have our routes.js. It's inside of source directory, it's called route.js, and we are exporting this constant here with the routes. In order to load the routes, we use import routes from source routes. How did I find this directory? I'm using a helper here in the extensions, auto import. So you can just type it in the Visual Studio Code, auto import, and it's very useful when completing imports. So we can just type it, import routes from, and the moment we start typing, we see the directory and then the available files which can be imported. So this is a very useful and time-saving feature provided by this plugin. And then we'll use those routes, so there will be like a middleware around our application. So we'll type routes application, we save, everything is accepted, so the routes are imported, we are using them inside of our application, we are connecting to MongoDB. This we don't need it here anymore because we moved our structure to a different directory for the routes. We're listening to certain port. Let's see the routes we have for the user and our specific user ID. If we go to our application and refresh, we see cannot get because we don't have the main route. But if we type user, we see getting information about our users, or a specific user, getting specific user by ID. With this we tested the main routes. In order to test the post routes, we'll use a specific application which is called Postman. You can get it for free. Here I'm using Ubuntu, so I got the 64-bit version of the application, and it's inside of the downloads folder. So now I'll go to the downloads and we'll unpack and run Postman tar -z -vf and then Postman. This will create its own directory. I'll go inside and run Postman. Okay, this is the application. You have to log in. If you don't have a free account, just create it now. So here we are inside of Postman and we can create our requests. Here the request URL will be localhost 4000, and here we can change all the methods we can use inside of this IP address. So let's try with the get request. We can click on send, and actually we see the response, and this is cannot get, this is the default response. If we get to the user's URL, we see getting information about all users. So Postman will actually help us to create such requests. All right, after having a convenient way of sending requests, now it's time to define schema for our project and use this schema in order to define our model. So we go back to the project directory. Inside of the source, let's create one new file, which will be models.js. Inside of this models file, we can place the following content. First, we are importing Mongoose, and we'll create a schema using a Mongoose schema. Afterwards, automatically we'll export this schema to be available for the other files, which will be importing this models.js file, which will be our index file. Why we are using schema? Actually, MongoDB is not requiring for us to provide a default strict schema for the document, so we can save all types of JSON structured documents. But if we would like to enforce certain kind of validation over our data before entering into the database, it's a useful place to do so. Here we are actually setting up for the user a schema which sets up a first name, last name, email, and where it is created. For the first name, we define it to be a type of string, and also here we have required parameter and the first name. For the last name is the same, the email, and also we use created at a field where we set it up to be date, and we fill it with the current date provided directly from MongoDB. Okay, this is the schema. Now let's see how we can use this schema. Out of this schema, we'll create a user, and then very easily we can use methods such as save, update, and delete. Also find. In order to work with the schema, we'll use a controller. So the controller works with the model, and the routes are redirecting our users to a specific controller to handle their actions. So here we create one new file, controllers.js. We'll import Mongoose, then we'll import the schema. And we'll import it from the model. Okay, once we have imported our user schema, we will use it. So basically, we will use mongoose.model, and we'll create a class user from this user schema, and we'll save everything inside of a constant user. So let's remember, user is class reference constant. In order to use this class reference constant user, we'll create a new user variable out of it. So we'll type let new user equals to new, and now we are instantiating the object out of this class. And here we have to pass parameters. Those parameters we can get from the body of our request. So we'll type request.body. This way, actually, we're passing the request body to our model, and automatically we'll be having created a new user inside of MongoDB once it passes its internal schema validations. Let's save this inside of a new function, add new user, and it will have a parameters request and response. And at first it will create the new user, and then since it's still in the memory, we'll save it inside of the database. So we'll be using new user .save, and here we have two functions. One is for error, one is when this save operation completes successfully, and it will give us a reference to our newly created document, which will save inside of the user variable. If there is an error, we'll just send the response, the error. In other case, as a JSON, we'll send what we have received from the save operation, and it will be the data of our new user. All right, to be able to parse the requests, and especially its body part, we'll have to add certain lines into our index.js. So we'll go here, and after defining our application, we'll use a certain type of middleware, and we'll add those two functions to parse two types of documents. So if we would like to parse JSON documents, we'll use express.json to parse information of type form URL encoded. We will use the following line: use express URL encoded where extended is true. So this second situation happens when users are submitting simple HTML forms with data. Okay, so once we patched our index.js, we can return to our controller, and once again take a look at our add new user function. It will accept request and the response. We'll create a new user out of the request body, and we'll try to save this new user inside of our MongoDB. In case of error, we'll send the error back to the response. Otherwise, we'll send in a JSON format the resulting user data returned from MongoDB. Now we have this add new user, and how we can use it inside of our routes. So first we'll export it in order to be visible. Now let's go to the routes, and here we'll import the same function from controllers under the post where we are creating our user. Actually, we would like to replace this response here to the user with our add new user function. So we'll just paste it here, and this way, whenever a new user is posting something, this function add new user will be triggered from our controller. Okay, so we go to Postman, and here we'll change from get to post requests again to the same user URL. Now for the body, we'll change it to be form URL encoded. We are actually emulating submission of a real form, and here we'll type key and value of the things we would like to fill inside of our requests. Let's go back and see what are those things inside of our schema. So we go to the model, and we see that we have first name, last name, and email, which are required to be filled. Let's fill them here. First name, last name, and email. And so far our request should be ready to be transmitted. Let's click on send, and let's show the response. We see this is the returned from our MongoDB response. We have already created one ID automatically and filled all this data, and also MongoDB has created the timestamp or the date and filled inside of our created at field. We can check this locally. If we go to our terminal, we will type Mongo, and let's see the databases we're having here. MyDB is the database we'll use. Let's see the collections. We have users, and we can type db.users.find, and we'll pass an empty search criteria, and this should show us the record. Let's even type pretty to see the things more beautifully, and that's the same record that we created using Postman from before. Okay, now the post request API is ready. Now we'll be fetching the information about all of our users. Again, we'll go to the Visual Studio Code, and here inside of our controllers, let's just copy this add new user function. We'll call it get users. Okay, here we don't need this new user variable. We'll just directly use find user.find, and we'll pass as a criteria nothing, and if we find something we will save it in a user's variable. Otherwise we'll return this found users variable inside of our response. And actually here we have to provide the parameter if an error happens. Okay, now our function is correct. So this should get the users. We are exporting the function name, and again let's go to our routes and import the same function as add new user, get users, and here we'll replace everything with the same function. And let's test the code in Postman. We click on send, and for now we have only one user and it's shown here directly. All right, we'll go back to our routes. We see that we have two more to fill in, and those will be fetching information for a specific user by its ID. Let's see how we can do this. Again, we'll go to the controllers and we'll use this last function as a blueprint. Okay, this time the function we'll call it get user by ID. Here we'll use not find but find by ID, and as a parameter we'll pass something from the request. So request params will give us the parameters that we can access directly from the request, and here we'll grab user ID as a parameter. The router inside of our application will grab the user ID directly from the request, and it will save it inside of this variable, and afterwards in the controller we are grabbing it directly from request params, and we'll be using it to pass it as a parameter to find by ID MongoDB function. Okay, if everything is ready, we'll be having this user here passed as a second parameter, and we'll be providing it as a response to the requesting URL. So since we created this function, again we'll copy the function and we'll use it in our models here. Let's import first the function. We can also format the code, and then let's use the function. So here directly we'll replace the content with our function get user by ID. Now everything is ready to be tested in Postman. Alright, so here we have to provide ID of a specific user. Okay, we'll just modify our user ID with 1 to see the returned result, and this is non-existing user returned. And let's provide now ID of an existent user, and we see that we successfully searched inside of our database and returned the data. And now the last thing that has been left is to fill the update function. We're going back to the code and we'll be using a put request. Let's go to the controller. Again, we'll copy the last one and we'll call it update user by ID. Here we'll use the MongoDB function find one and update. First, this function requires a condition, so we'll have to provide what we are looking for. We'll be finding users by ID, and again from the request we'll be providing the same parameter. So I will just copy the code. Actually, the function requires the data with which we are about to update this record. We can get this data directly from the request, and this is actually the full body of the request. And we'll send certain parameters. So we would like with new set to true to return the newly created object as an output, and then we will set another option just to suppress certain errors. It is called use find and modify, and it will be set to false. Okay, you don't need to worry about the second option for now. We can write here updated user, and we'll send this updated user, if the update goes correctly, as a response. And that's it for now. Let's use this updated user by ID function inside of our routes. Okay, and then for the put requests, again we'll fill the body of the function with our new function update user by ID. And let's test in Postman. As you can remember, we'll have to create a put request for updating a certain user. Here we're passing the ID of the user we're trying to update, and then again here we'll construct some of the variables we're about to update. Let's say that we would like to update the first name, and it will be Josh. And let's click on send. Once again, we are sending a put request. Send. And now if we scroll down, we can see this is the updated result. If we go back again in the terminal and again use the same command, we see now that John has been updated to Josh. So you can create the delete requests very easily by using a remove function from within MongoDB. And if you had enjoyed the information, you can subscribe to the channel.